All right, guys, I'm going to get started. Like I did with the previous ones, I'll be posting this later today online. So if you don't get it today, no worries. Okay, so we're going to start today and talk about volume. So if length is a measurement of one dimension, area is a measurement of two dimensions, volume is a measurement of three dimensions. So it has a length, a width, and a depth, and therefore it has some volume. So in general, volume is the amount of area taken up in a 3D form. And we're going to talk a lot about this kind of shape called a prism. A prism is a 3D form where the base and the top are congruent polygons. So here, you notice I have a square, and here I have a square as well. That makes it a prism as long as the top and bottom are the same shape, and they're what we call a convex polygon, so it doesn't have an irregular shape. It's a very regular shape. So it could be a square, could be a circle, it could be a trapezoid, parallelogram, any convex regular shape. So it doesn't have any jagged edges or anything like that. And as long as that's the case, and the sides, you can measure the height here, which is always perpendicular to the base, the width and the length. And for this kind of prism, which is a rectangular prism, having a rectangle as a top, that volume is just length, width times height. Keep in mind that the general form of this will be area of the base times the height. I'll show you that on the next one. So volume is the 3D amount of space a 3D form takes up. I see a few people just joined us. So I'm going to hold this up for a couple more seconds and talk about it a little bit more. So if you're just joining us, we're talking about volume today. Volume is the amount of space taken up by a 3D form. We're going to talk a lot about a certain kind of form called a prism, which is a form in which the top and bottom are congruent shapes. They're congruent polygons. We measure the height as always being perpendicular to the base, length and width, and the volume for a rectangular polygon, which means it has a rectangle as the top and bottom, will be length times width times height. Okay? All right, I'm going to move on to the next frame. I'll give you guys a couple seconds to copy this down if you need to. Once again, I'll post this afterwards, so no worries if you're having trouble taking up. Okay. Now let's talk about volume of prisms a little bit more in depth here. So the volume of prisms in general will always be the area of the base times the height. But the trick to remember is that the height is always perpendicular, and that's what this sign means. It means it's at a right angle to the base. So if you notice in these ones, this form, and this form, we all have perpendicular heights. In other words, the line on the form here is one of our heights. But in this shape here, since it's slanted, the height is not one of the lines on the form. Instead, the height is this line here, which is perpendicular to the base, so it's at a right angle to the base, and it tells you exactly how tall the form is. So the height is, in a sense, if you lay the prism flat on its base, how tall is it going to be, right? So even though this has a slant height, we do not measure this side as the height. Instead, we take just the vertical distance, as long as it's perpendicular to the base. So even though all these shapes are different, we have a square, parallelogram, triangle, circle. In every case, to get the volume, we need to get the area of the base and multiply it by the height. So in this case, we do length times width for the area of the rectangle. For this parallelogram, we can do base times height, and then times it by the height. For this triangle, we could do 1/2 base times height to get the area here, and then multiply it by the height. And the circles here, this cylinder, I'll show you in a second, we'll get the area of the circle, pi r squared, and multiplied by the height. So no matter what type of polygon is at the top of our prism, or if the prism is slanted or not, the volume of a prism will always be the area of the base times the height. So you have to know how to get the different areas of the different bases if you get stuck. Okay, give this a couple more seconds. All right, cool. Lastly, I want to talk about forms that are made with circles. Okay, so we have three dominant ones for circular forms. We have the cylinder, the cone, and the sphere. The cylinder is a prism, just like we did before, where the top and bottom are circles. the formula for a prism still applies here. It's the area of the base times the height. In this case, the base is a circle, so I get pi r squared as my area of a circle. I just want to fix this because it looks a little confusing. Okay. So we're multiplying the area of the circle, which is the area of the base, and we're multiplying by the height, pi r squared h. Pi times the radius squared times the height. Hold on a second. I apologize for that. Okay, so back to the cone. The cone is very much like a cylinder. The only difference is that instead of having a top that's a circle like the bottom, it just has a point. The formula here is actually very similar. It's still pi r squared h, because we take the area of the base, the circle, pi r squared, multiply it by the height. Once again, the height is perpendicular to the base. It is not this slant height. So it has to be straight up and down. And we just divide that by 3. So in other words, the cone with the same base and circle has 1/3 the volume of a cylinder. Okay. And lastly, for circles, we take a familiar form, pi r, and instead of taking it pi r squared, we're going to do pi r to the third, because we're working in 3 dimensions here. And we just multiply this quantity, pi r to the third, by 4/3. So it can be written as 4 pi r cubed divided by 3, or 4/3 pi r cubed. And that's how you get the volume for circular forms. I'll leave this up for you for a second, and I'll post his notes after the lecture if you miss it. All right, cool. I'm going to open it up for questions. If you guys have any, you can ask them now, either on the chat or with your audio. And if you don't have any questions, thank you for joining me, and I'll talk to you guys later. Peace.